called integration by parts. It's a good one for the 5 days. So I think it'll be cool. I don't know whether this is on your bright colored sheet of paper. So we'll look in a second. But it's really not. I don't know if it's on there, so if you don't mind looking under integration and seeing to see something that kind of resembles that.
It's there.
It is, it's like that?
Yeah.
Yeah.
But it's a dv over dx.
Okay. Like that.
And then on the end it has a dx next to the dv view.
That's silly. Okay. I'm just gonna run it like that.
Okay.
Okay. Because dx is canceled. So it's kind of silly. Okay, so when do I use something like this? So if I ask you to integrate something that looks like this, okay? Step one in recognizing whether we can utilize integration by parts is when you have two items that are trying to be integrated that have absolutely no relationship to each other. However, they both have x's in them. So if I'm looking at this, do you recognize that I have an x and then I have an e to the 2x? There are two items that have no relationship to each other, x and e to the 2x, but they both have x's in them. Does that make sense so far? Are we cool? Okay, so for us to do that, we're going to be utilizing, so one of them is going to be referred to as u, and one of them is going to be referred to as dv. So we have to kind of be calculated as to which one we want to have as u and which one we want to have as dv. So oftentimes when we're doing this, what I do is I look at the both components. The dx just means I can take an integral of it. I'm good. So if I'm looking at this, I try to take the one that I could derive until I hit 0 to be called as my u. So if I'm looking at this, one is x, one is e to the 2x. Which one of those two could I derive, take derivative of, until I hit 0? X. So tell me what would happen. I'd have x, its derivative is 1, its derivative is 0. So that's the one I am going to call my u. So my u. So the first thing I'm going to do is label u is x. Are we okay so far? Now, if u was x, the other guy is dv. So dv is e to the 2x. They have to be one or the other, okay? So the first thing I'm going to have you do is I'm going to have you find the derivative of u. So what is the derivative of u? You all told me that a second ago. 1, because the derivative of x is 1. And then I'm going to go back, because if I'm looking at this, the things that I'm going to end up using are u, which we have, v, which we don't have over there, and then v, which we don't have, and then du. So how do I go about finding v?
Integrate.
I integrate. So I'm going to integrate this guy. Ooh, so what's the integral of e to the 2x? Anybody remember?
1/2 e to the 2x.
1/2 e to the 2x. You rewrite e to the 2x and you divide by the derivative. So 1/2 e to the 2x. All right, slow me down if you don't quite see what I did. I have two things make no sense to each other. I call one u and I take its derivative. I call one dv and I take its integral. All right, are we cool so far? And the formula says to find the integral of it, you're going to write u times v. So what is u times v in this case? So u times v,
1/2.
1/2 x e to the 2x, minus the integral of, back over here, v, what's v? 1/2 e to the 2x, and then du, what's the derivative of u? Up here? 1, so times 1. All right, have I lost anybody so far? So I named one u, I called one dv, I derive, I integrate, and then I plug it into this, uv minus integral v du. All right, now let's just clean it up a little bit. So I have 1/2 x e to the 2x minus, if I kind of look at this, can I integrate this guy? So does the 1 have any bearing on this problem at all? Not really, right? Can I integrate 1/2 e to the 2x? What would the 1/2 e to the 2x be?
D2x.
So it's e to the 2x, and then what do I do with that 1/2? Make it go for the ride, and then what do I do when I integrate e to the 2x? I divide by 2. So really, if I kind of show the work, 1/2 divide by 2, can that 1/2 divided by 2 become something else? 1/4. So I'm going to clean it up a little bit. I would have 1/2 x e to the 2x minus 1/4 e to the 2x plus c. And that is my integral. Are we cool with it so far? Yeah? Okay. Did I rock anybody's world? Not yet? Maybe?
No.
No, okay. All right, let's do the next one. Integral of x squared sine x. Okay, so one of them I have to label as u, one of them I have to label as dv. Okay, which one am I gonna label as u?
X squared.
X squared. And then the other guy is sine x. Okay, now I'm gonna find du, so what's du?
2x.
And what's v? Yeah, because the derivative of sine is cosine, right? And the derivative of cosine is negative sine, so the integral of sine would be negative cosine. You can also look at your bright colored sheet of paper. I believe they give it to you there, right? Okay, so have I accomplished my task of finding a u and du and dv and v? I think I'm good. So uv minus the integral of v du. So if I I'm gonna write it out, hold on. Negative cosine of x times 2x. So can I clean this up a little bit, like this negative, can I do something with that?
You can take it out.
I can pull that out. So negative x squared cosine of x plus, and then I'm gonna put 2x in front. Can I integrate 2x cosine x? Are these two things that have both x's but have absolutely nothing in common?
Oh. Yeah.
So what do I do?
Do it again.
Do it again. All right, so let's write that down. Okay, so I'm just gonna rewrite it. I've got negative x squared cosine of x plus 2x cosine of x. Now no, this part right here is actually complete. I just kind of bring it for the ride. I just have to redo this piece. So what do I get? What's my u and what's my dv here? Yep, u is 2x. And what's dv?
Cosine x.
Okay. What is du? 2. And then what's v? Sine. All right. How do we feel? Okay, so I have negative x squared cosine of x, and then plus, and then what do I do with this? Well, I'm just gonna do uv minus the integral of v du. Can I integrate that?
Yes.
Okay, so I'm gonna rewrite this, negative x squared cosine of x plus 2x sine x. And then, help me out, the 2's gonna go for the ride. What's the integral of the word sine? What kind of cosine? Negative cosine. So this becomes positive cosine plus c, and I'm done. Is it horrible or not? Are we cool so far? Hmm?
So that's just the answer.
Is it- And that's truly part of, like, I have another type, and then I have a shortcut, and that's the lesson. That's all I'm gonna do is this technique this week. Yes,
Will there be one for A's and B's as well?
no A's and B's. Literally what we're doing, and they really do like to give one of these on an ACE exam. So if you recognize two things that have nothing in common but both X's, and you recognize this, they're like huge points. 6, 7, 8, 9, 10 points for these, because it's almost like a Calc 2 topic. So, all right, what do we think so far? Okay. So, what was my criteria for you?
It can drive and hit zero.
You can drive into 0, right? It has an ending part, basically. But not only does it have to be able to drive to 0, you need to be able to take an integral of the other component. Does that make sense what I just said? It's nice if it can drive to 0, but if you can't integrate the other piece, then you're kind of out of luck. So let's look at this example. We have x ln of x. Naturally, what would we want to call u? X, because I can drive it to the number 1, and then I can drive it to the number 0, right? On the flip side, what is the integral of ln of x?
1 over x.
What is
Wait.
it?
Is it 1 over x?
There isn't.
There isn't.
I'm looking at integration.
Yeah. No. So there are no integrals of ln of x. So then what do I have to do? If there's no integral of ln of x, what do I have to make u? Ln of x. Okay? So if you're writing yourself little notes, understand ln of x can never be your dv because you can't integrate it. Are we okay so far? All right. So what is du and what is v? What is the derivative of ln of x?
1 over x.
1 over x. Sweet. And then what's the integral of x?
1.
1/2 x squared.
X squared over 2, 1/2 x squared. Okay. Are we cool so far? uv minus integral v du. So u and then v minus the integral of v du. Notice I took the 1/2 and just pulled it up front. Bless you. So what do we think? Good, bad, ugly, indifferent? I took the 1/2, pulled it outside, because it just goes for the ride anyway. So can I do any algebra before I integrate? Is there any algebra to be had? Like x squared times 1 over x, what's that? Just x, right? Can I integrate just x? What is it? X squared over 2. So it's 1/2 ln of x times the x squared minus 1/2. The integral of x would be x squared over 2 plus c. You can clean that up to be x squared over 4. What do we think? Good? Not so good? I get it? I don't get it? Good question. Okay. What about this one? This one's a little tricky. We just got done saying there's no such thing as an integral of ln of x, right? Yeah. What's u? So u is ln of x. What's dv? 1 dx. Does that make sense? Just 1. Does that make sense?
Yeah.
Oh, good. First class I've ever had that understood that.
No, it doesn't make sense. I'm confused.
Okay, what is in front of, remember dx just kind of goes for the ride? So really what's in front of it? It's the number 1. It's just
Like a placeholder kind of.
kind of, yeah. So like over here, we obviously saw x dx. And we could actually, I could actually take the 1, I could do 1 ln of x dx. So this is u, this is dv. Does that help? Yeah. So could you, what is du? 1 over x. And what's v? Just x, right? So uv minus the integral of v du okay, and so what do we get? X ln of x, and the integral, so minus the integral of 1, and what's the integral of 1? Just x. So x ln of x minus x plus c, done. So how does this change? If I have an a and a b, and do I need a plus c? No, I could plug in the b and the a and subtract the answers. That's like the next part, a lesson. What do you think so far? So far, so good. Okay, so I'm going to show you the chart method. So not a lot of teachers will give you the chart method. It's going to work for pretty much everything except for natural logs. It's a no-go for natural logs. You have to do what I showed you here. You don't get it?
No,
You good? Okay. Okay, what's the first one that I wrote down that we did? Can you guys give me that question?
It was x e to the 2x.
Okay. Hi.
Who?
How are you?
Good.
Want to hang out? You taking your test?
Yeah.
All right, gotcha. X e to the 2x. You all know how to do it with uv minus integral v du, right? You label your u, you label your dv, you derive, you integrate, you plug it all together, you're good. I'm going to show you this thing called the chart method. You might like it, you might hate it, okay? So the first thing I'm going to have you do is label 3 columns. The first one is sine, u, and dv. Okay? So under the word sine, that means positive or negative. So I'm going to have you start with plus, minus, plus, minus. I don't know how far I'm going to go, so I'll do 4. I may need more, I may need less. Always start with plus, all right? What is a u and y? What would the u be when we did it a minute ago?
Is it x?
And y?
Because it eventually derives to 0.
Because it eventually derives to 0. It doesn't involve an ln of x, right? So I'm going to put x, and then I'm going to derive it until it hits 0. So the derivative of x is 1. The derivative of 1 is 0. That's as far as I have to go. I got rid of the last minus. So step 1, sine, S-I-G-N, plus minus, your u, and derive it till it hits 0. Again, ln of x will never work for this. Okay, so what's the other thing that I need to label? dv, which is e to the 2x, right? What is the integral of e to the 2x? So it's 1/2 e to the 2x. Any comments or concerns about that? You rewrite it and you take the derivative of the exponent and divide by it, basically. Okay, do another integral of that. So what would the next integral be? So 1/4 e to the 2x. Okay, any questions so far? Are we cool or not at all? We're good? Okay, so here's how this works. You are going to start with this plus. You're going to come across and diagonal down. And then you go to the next sign. You're going to come across and diagonal down. Once I've hit the bottom of the DV, I'm done going across and down. Are you cool with what I just did? Top left, cross down, top left, across down. If there's more, I'd go across down until I was done with that. So what you're going to do is you're going to multiply that first red line all the way across, plus x 1/2 e to the 2x. So you have positive 1/2 e to the 2x, basically times x, right? And then what's the next guy going to be? Negative 1/4 of that. So minus 1/4 e to the 2x. Look at the answer we got for that first one. Let's see. What do you guys think? It's super cool. It's really easy. Across, down, voila, you have your answer. It does not work for natural logs. You can't.
So it's like, it's adding this way or is it multiplying?
Multiply. So you multiply across, and then combine them by adding after. So it's this guy plus this guy,
Okay, so sorry.
multiply, plus, multiply, plus, multiply. Like, I multiply, then I add it to this guy when I multiply. No? How do I say that nicely? I don't even know how to say it without making a mistake out of it. I'm going to multiply the red line, and that's this.
Yeah.
And then I'm gonna multiply the red line, and then I'm gonna combine them together.
Oh, okay.
Does that make sense?
Yeah.
Okay, cool. Yeah, I don't even know how to make, I don't know. I guess on 3 hours of sleep, I'm not.
For
Yeah.
like the last column, like how do we know when to stop? Cause like you said, like you just keep.
Going till you hit the last guy.
Yeah.
Like if there was more down here, you would come across and down to it, but there's nothing there.
Oh, because you're multiplying by.
It's the bottom, you go across and down until you hit the very bottom of the DV.
But like, how do you know when to stop?
Yeah, that's what
So
I did.
I don't know.
When you hit 0 here.
Okay, so
Oh,
stop
yeah,
at 0.
when you hit 0 here.
Oh, okay.
Because there's no, if you derive again, it's another 0.
TV, like even with the like the 9 zeros, which you have, should be.
Like you should have the same amount of rows.
Yes.
Okay.
And then if you think about it, if you went further, you would do plus times 0 times something. And what does 0 times anything? It's just 0, so it would just 0 out for then on.
Okay.
Does that help? Okay.
Thank you.
Let's do another. X squared sine x. I did that right with you all? X squared sine x?
Yeah.
Okay. Okay, what's u? Okay. U is going to be your x squared. Are you guys cool with that? So we have the word sine, u, and dv. So we start with plus, minus, plus, minus. I don't know how far I'm going to go. Okay, what's u? And then tell me what to write in that column. 2x, what's next? 2, then what's next? 0. That's where I stop. Does that make sense? All right, my dv is the word sine. All right, what's the integral of the word sine? Okay. What's the integral of the word negative cosine? Negative sine. And then what's the integral of negative sine? Positive cosine. Are we good? Are we cool or not? So we're going to come across the top, down, across, down, across, down. Remember when we did this one, I actually said, ooh, we have the x's again and we have to do it again. It's third layer. That's That's your third layer coming into play. So what would this be? It would be negative x squared cosine of x, and then plus 2x sine of x, and then plus 2 cosine of x plus c. Is that what you guys got when you did it the first time?
Yeah.
That was cool? You don't like it at all?
Oh, it's great.
It's the not the
wonderful.
derivative. It's the integration for me.
The integration.
Yeah.
Well, that's probably something we have to practice.
I understand sine to negative cosine, but not negative cosine to negative sine.
Okay. I get what you're saying. All right, what do we think?
Yeah. I like the trick, it's nice.
Do you like my trick?
Yeah, I'm very visual, so it's good.
It's a kind of cool little, yeah. I can't claim the fame to that one.
Oh,
Have you ever watched,
Schoolhouse Roll.
it's a story about Jaime Escalante. Stand and deliver. If you've got nothing to do, it's a good show. All right. Can I use the chart method? I think I call it the table method. Can I use the table method? Yes?
Looks like.
Table plus minus
No,
that.
is it called the chart method?
It's table method. It's actually table method. I think. I never called it by its name. Tic-tac-toe. The easy method.
How does Cambridge grade it? Is it like, were they graded the same?
They don't care, as long as you're doing it. Yeah, they don't care.
It's also faster to see.
I don't know whether a whole lot of teachers teach this method, but why not if you're getting it?
It's also faster too, so.
Much easier too. Okay, what do I do here? So plus minus, how many do I do? I don't know. I'll do 4 for now. I might have to go back and do more. All right, what's my u? 4x. What's du?
4.
4, and then one more.
0.
0.
So I don't need that last guy.
Yeah.
Okay, dv is,
Sine 2x.
what's the integral of sine 2x?
Negative 1/2 cosine 2x.
Yes.
Okay.
What's the integral of negative 1/2 cosine of 2x?
Negative 1/4
Negative 1/4
sine.
sine of 2x.
Dang, Connor, okay.
What do we think? Bad, ugly, indifferent? I get it, I don't. What are you doing, Miss K? Are you speaking a foreign language?
That was silly, I need that.
Are we good? Okay, then what do we do?
Lines.
Cross down, yeah, tic-tac-toe, 3 in a row. Write it all out, friends, write it all out.
Oh my gosh.
I'm giving this up for real.
2 negative.
Oh.
X plus sine x 2 times.
Now, what happens if in the beginning I did this? From 0 to pi over 2.
Yeah, oh my gosh.
Yeah, get excited on me now. I don't do a plus c, what do I do now?
Just
You
plug it in.
plug them in.
Plug in pi over 2 and then plug in 0 and subtract your answers. So give that a whirl. I know.
Okay, I was there. I was just there. Mental math is actually scary. I don't know. How do you prove?
That's 4. I didn't go. That's 4. I know, but like.
Okay, where do we go? This right here is, the 2's reduced, so we have negative pi. Are we there? Good. Cosine at pi. So
Negative
because the
1.
2's cancel, what's the cosine at pi?
Negative 1.
Negative 1, right? Okay. Sine at pi.
1.
So that pi is 0.
2.
0, yeah. So plus 0 minus parenthesis, 0 times anything?
0.
0. And what's sign at 0?
0.
0. So we have negative pi times negative 1 plus 0 minus 0 minus 0. So pi is the answer. What do we think? Yeah? Good?
Yeah.
Feeling it. Okay. Okay, so any questions about that? Yes, no? Are we good? Okay, so that is my lesson for the week.
Oh.
And